Guys, Mr. Gucci with his last homework help video. Now we're going to do number 11, 12, 13, and 14. Okay, I'm not going to do the rest down here, nor the bonus. Okay, these last ones are just based off of the notes. Okay, so I just want you to finish that up. Okay, you'll use the notes to answer those last ones. This video, though, is just going to focus on 11, 12, 13, and 14, which is noble gas configuration. So here's how noble gas configuration is. It is a shortened way to write an electron configuration that replaces a large chunk of the configuration with the name of one of the noble gases. So basically what we're doing is, for example, in this case, the full electron configuration for phosphorus down here is, let's see here, the full electron configuration for phosphorus is 15 electrons, 1s2, 2s2, 2p6, 3s2, 3p6, but everything up to 2p6 is the electron configuration of the element neon. The configuration of neon is just 1s2, 2s2, 2p6. So what we'll do is we will look for that 2p6 and we will delete everything that comes before it, including it, and we will just replace it with neon. So the noble gas configuration is just Ne in brackets, neon, 3s2, 3p6. So that's what you're going to do. I'm giving you the full electron configuration, and you just look for the last p6 that you see appear, all right? And then you erase it and everything that comes before it, and you replace it with one of these appropriate noble gases. Okay, so if the last full p6 is a 2p6, and you erase it all and replace it with neon. If the last one you see is 3p6, you erase it all and replace it with argon. If the last thing you see is 4p6, you erased it all and you replace it with krypton. Okay? And if the last p6 you see is a 5p6 and you erase everything and you replace it with xenon. Okay, it's easy to see once we get to doing it. So let's take a look here. Okay, so here's the electron configuration for tin. 1s2, 2s2, 2p6. So what we're doing, we're going to read through it and we're going to identify where we see a p6. Okay, so here, reading through. Okay, so we got a 2p6. Okay, I'll start to draw now. I just draw. So we got a 2p6, okay? We got a 3p6, keep going. We got a 4p6, and this is the last p6 that we see. So what I'm going to do is I am just going to erase this 4p6 and everything that comes before it. I'm just going to erase this 4p6 and everything that comes before it, and I'm going to, why don't you just do it? Okay, so here we go. I'm going to copy and paste it. Doesn't want to cooperate. Copy, paste. Okay, so everything before this 4p6, including it, it gets erased. All right, I erase it. And for 4p6, I replace it with krypton. Okay, so the noble gas configuration here is just krypton, 5s2, 4d10, 5p2. That krypton right here, this krypton is standing in for all of this. That's the electron configuration of krypton. Okay, so instead of writing all that, I just write krypton. Okay, next up is nickel. All right, next up is nickel. So nickel, 28 electrons. All right, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. I go through and I look for the last p6 in the sequence because here's a 2p6. All right, here's a 3p6. And that's the last one. So what I'm going to do is I am going to erase everything from 3p6 back. Okay? Everything 3p6 and back gets deleted. And for 3p6, I'm going to replace it with argon. All right? So the noble gas configuration here is argon, 4s2, 3d10. Because again, instead of writing all that stuff, all right, I'm going to write argon because this is the noble gas. This is the electron configuration of argon. So I just swap it out. Okay, next up, Gold. Gold. Okay, so going through, let's see here. 1s2, 2p6, there's one. 3p6, there's another one. 4p6, is there 5p6? Yeah, 5p6. And there's no 6p6, all right? So this is it. I am going to erase 5p6 and everything that comes before it. All right, so here we go. I'm going to erase 5p6 and everything that comes before it. And I replace 5p6 with xenon. All right, so there I go. So replace it with xenon. So instead of having to write all of this stuff right here, all right, instead of having to write all of this stuff right here, I just write xenon, okay? Because that's the electron configuration for xenon. So I'm just going to replace it with xenon. That is the noble gas configuration. Okay, now why scientists are able to do this? They can do this because ultimately what's important in in an electron configuration ultimately is the last electrons that you place. Those first electrons that you place, all this other stuff, these are just placeholders essentially, okay? So really what matters is the very last electrons that are placed. So as a chemist, you can write this noble gas configuration and you're not really losing out on anything because it's only these last electrons that really matter, okay? Cool. Last up, we got cesium. Okay, so cesium is element number 55. Okay, and I'm going to spare you the task of going through all this. I'm just going to copy this, place it in. Okay. Now I know that cesium ends on 6s1. All right. Let's just pretend I did all that work and ended on 6s1. I can double check. I can add all of these electrons together. 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 6 plus 2 plus 14 plus 10 plus 6 plus 1. All of that, add it together. I get 55. Okay, I get 55. Now, what I'm going to do is I'm going to go through and I'm going to identify every P6 that appears. Okay, here's one. There's one. There's one. And here's the last one, 5p6. So just like every other one, I'm going to delete 5p6 and everything that comes before it, and I am going to replace it with 5p6 xenon. I'm going to replace everything with xenon. So you can see here how some electron configurations just get a whole lot simpler when you do the noble gas configuration, because everything here is just the configuration for xenon. All right, that's it, guys. That's your last help video. I'm going to attach it, and I hope it helps you answer your question. All right, good luck.